Voyager 1 has evolved beyond its initial role as a spacecraft. It stands as humanity's inaugural starship. Launched in 1977, it marked an era when reaching the outer planets felt monumental. Now, nearly 5 decades later, it drifts beyond the Sun's protective reach, exploring interstellar space and yielding discoveries that astonish scientists. Many believed its instruments would gradually dim and eventually fall silent in the deep void of space. Instead, Voyager 1 has defied expectations, revealing strange phenomena that continue to puzzle even the most seasoned astrophysicists. As it journeyed past the heliopause, the boundary where the Sun's solar wind loses power against the galactic medium, Voyager 1 detected unexpected phenomena. Its instruments recorded fluctuations in plasma density, structured waves, and magnetic disturbances contradicting previous assumptions about a calm, featureless void. Scientists believed the interstellar medium was shaped primarily by distant supernovae and faint galactic currents. However, Voyager unveiled a world of turbulence instead, waves of charged particles moving in patterns reminiscent of echoes at the solar system's edge. Even more remarkable is the endurance of these signals. As Voyager ventured deeper into interstellar space, scientists anticipated the plasma oscillations would diminish. To their surprise, they remained robust, suggesting that the solar system's boundary is not a distinct barrier but a living frontier. The heliopause, once viewed as a simple wall, now seems dynamic, an unstable region where solar influences collide with galactic forces. This revelation challenges scientists to reconsider the nature of our solar system's shield. If these waves act as channels, cosmic radiation might penetrate far more easily than previously thought. Consequently, Earth's protection from galactic radiation may be less certain than once assumed. The spacecraft also captured an eerie phenomenon, a steady, low-frequency hum echoing through interstellar space. This persistent note could stem from vibrating interstellar gas influenced by ancient supernova shock waves or may hint at an underlying mechanism yet to be understood. Regardless of its source, it confirms that the cosmos is far from silent. It resonates with hidden structures resembling a kind of cosmic music, too faint for human perception but detectable by Voyager's aging instruments. Scientists are particularly intrigued by the order found within these plasma waves. While random turbulence is easily explained, the patterns captured by Voyager suggest an organized presence governed by unseen rules. Some theories propose that galactic magnetic fields weave through space like invisible rivers, shaping plasma into waves. Others suggest that ripples from long-dead stars spread out over millions of years, intersecting with the solar system's boundary. Yet, none of these theories fully account for the coherence and persistence of the observations. It appears that the solar system resonates with the surrounding galaxy, creating a complex interaction zone we are just beginning to comprehend. This revelation has profound implications. For centuries, humanity envisioned the solar system as a secure island within the Sun's grasp. Voyager's discoveries suggest a different reality. The boundary is not a fixed line but a fluid, vibrant interface. Each star may inhabit a similar turbulent plasma sheath, influencing not just its own solar system but the larger structure of the Milky Way. The galactic environment may play a more active role in shaping stars, planets, and potentially life itself. Voyager 1's remarkable journey is itself a crucial part of this narrative. Designed in the 1970s, its instruments were never intended for interstellar plasma research. The plasma wave detector, originally meant to study solar wind, has become humanity's first tool tuned to the cosmos's melodies. There's a poetic quality in this. A device created for a specific purpose has transcended its intended use to unveil mysteries beyond its designer's imagination. This exemplifies a timeless aspect of exploration. Meaningful discoveries often arise from persistence, not mere intention. The implications reach far beyond the realm of astrophysics. If the heliosphere is porous and unstable, our planet's exposure to cosmic radiation may have fluctuated over time, shaping the evolution of life. The rise and fall of ecosystems may not only reflect local catastrophes like asteroid impacts or volcanic eruptions, but also variations in the solar system's boundary. When searching for habitable planets orbiting distant stars, scientists must factor in how a star's protective shield interacts with the galaxy. Some worlds could face perilous radiation, while others may enjoy protection within calmer galactic regions. Voyager's discoveries resonate culturally as well. For centuries, humanity viewed space as a silent void devoid of substance. Now we understand that it vibrates with plasma frequencies and echoes of cosmic events. The universe is not merely emptiness, it is vibrantly alive, rich with harmonies waiting to be acknowledged. Scientists have even transformed Voyager's plasma waves into sound, producing eerie tones that allow us to hear the faint music of the galaxy. It serves as a reminder that the universe communicates, provided we devise the means to listen. For humanity, Voyager's impact transcends scientific boundaries. It is also deeply psychological and spiritual. Each time we crossed a boundary, be it land, sea, or sky, we reshaped our self-perception. Voyager crossing the solar system's threshold has similarly altered our understanding. It illustrates that even what we perceive as borders are alive, dynamic frontiers, reminding us that the universe remains. There is no boundary dividing us from the galaxy. Voyager 1 has shown us an ongoing dialogue within a blending zone, where inside and outside lose significance. This understanding transcends scientific realms and delves into philosophy. It implies that separation is merely an illusion. Even in the vastness of space, everything is intertwined by invisible forces of energy and motion. For humanity, often defined by divisions and borders on Earth, Voyager's message is profoundly humbling. The universe is united, not divided, by hidden currents. Voyager's journey compels us to reassess our concepts of time. Traveling at astonishing speeds, the spacecraft will take tens of thousands of years to traverse even a small portion of the interstellar medium. The plasma oscillations it detects may be ancient echoes of supernova explosions from millions of years ago, their shockwaves still resonating through the galaxy. Hence, Voyager becomes the first human instrument to capture the galaxy's memory, interpreting the plasma that contains history. Every signal received by Voyager evokes whispers from the ancient past, reminding us that each star and system bears the scars of historical events. The solar system's edge, once deemed a spatial boundary, now also represents a temporal one, offering a glimpse into the cosmos's history. The most significant lesson from this discovery is that the universe resists oversimplification. Humans seek clear boundaries and distinct categories, but Voyager has illustrated that the cosmos is infinitely more intricate. The solar system's edge is neither completely inside nor outside, silent nor chaotic, but a mix, a zone of resonance, interaction, and flux. Embracing this complexity necessitates understanding that exploration involves engaging with a continuous, unfolding process. Every mile Voyager travels adds to the mystery. The spacecraft is not entering a void but a realm rich in forces beyond our comprehension. The plasma hum it senses is measurable and undeniable, yet it challenges our models, stretching both scientific and imaginative boundaries. Voyager demonstrates that the edge of the solar system is not a barrier but a vibrant threshold, where solar forces encounter galactic ones. It provides humanity with a renewed vision of its cosmic position, not isolated, not silent, but connected and an integral part of a larger whole. These insights reverberate beyond astrophysics, impacting fields such as planetary protection, theoretical physics, cosmic mapping, and even philosophy. One compelling implication suggests that the galaxy may harbor concealed channels of energy and communication. Plasma physics indicates that charged particles can organize themselves into filaments and waves that endure across vast distances. If this scales, Voyager might have grazed the very essence of galactic architecture. Instead of isolated stars, we may find interconnected nodes in a vast cosmic web, linked by plasma currents transporting energy and matter. If accurate, this means Earth is influenced not just by the Sun but also by energy and material flows spanning light years. This perspective alters our understanding of life. If plasma channels shape interstellar space's chemistry, then life's fundamental building blocks on Earth could be connected to galactic processes. Life, from this viewpoint, is not merely the result of one star and one planet but the product of a galaxy spanning cosmic exchange. Voyager's findings even open the door to speculative ideas. Perhaps advanced civilizations utilize plasma resonances for communication. Unlike fleeting radio waves, plasma oscillations can persist along magnetic structures across immense distances. While Voyager's hum may be natural, it sparks the possibility that plasma itself could serve as a galactic-scale language, one humanity is just beginning to recognize. The implications extend to future space travel endeavors. Interstellar space is not a tranquil void, it brims with turbulence and energy. This environment could challenge spacecraft operations, interfering with instruments or communications. Yet, it might also offer opportunities. Just as Earth harnesses renewable energy from winds and tides, plasma oscillations could be harvested to support long-duration missions. Voyager may have stumbled upon not only a scientific puzzle but also a resource for future explorers. This discovery challenges our traditional views on borders. Humanity has always marked edges, horizons, continents, atmospheric boundaries, and the Moon's orbit. However, every time these lines were approached, they blurred into gradients. The Solar System's boundary is proving to be similar. It represents not a sharp break but a liminal space, a dynamic threshold of interaction. This demands a fresh perspective, one that sees boundaries as fluid continuums rather than fixed barriers. Future galactic maps may depict not only stars and planets but also plasma flows, turbulence, and resonance zones, much like how ancient sailors charted winds and currents. Voyager's detection of coherent plasma waves raises further questions in physics. Plasma's sensitivity to magnetic fields suggests that the detected patterns indicate organized galactic magnetic structures, potentially more so than previously understood. This connects with broader cosmological mysteries, including dark matter and dark energy. Some anomalies observed in galaxies may not solely arise from unseen matter, but rather from plasma dynamics on a grand scale. Voyager's data offers an initial glimpse into how visible matter and invisible forces might interact in ways yet to be unraveled. Additionally, these revelations extend to the life cycles of stars. If plasma resonances ripple throughout the galaxy, they may influence star formation, death, and energy.